Please. And many of you are asking, sir, can you please take this classes live? So, my dear warriors, I have listened to your comments and I am live over here. Hello, welcome, welcome. Hello, Dark. Hello, Dhari Sadra. Good evening, my dear warriors. And today we're going to do the April attempt questions of capacitors and current electricity both. So, oh my God, wait a second. How? Okay, looks like the session is playing. Okay, so that means we are live. Okay, perfect. Right. Looks like I'm audible and visible to all of you too. Hi, fan of Virat. Good evening, my dear students. This is your Captain Shreyas. I am a physics master teacher at Vedantu and have been training kids for more than 13 years now. And this year, I want all of you to use all the resources, whatever possible, because JEE 2025 will be very, very competitive. You saw that in 2024, how the marks went up, how the percentiles, have been inflating. So, my dear students, do not take any chances. Make sure you are doing all the PYQs, whatever resources, be it the ROAR series, be it your textbooks, be it your assignments, DPPs, make sure you are on track because hardly any time is remaining. Okay, so let's begin the session. And have you marked your attendance? Hi, Dharisida. Hello, everyone. Hi, Thaya. Have you marked your attendance by liking? And I hope you have subscribed to the channel. Very good. If you have done that, if you have not done that, you have not given your Guru Dakshina, then the knowledge will not enter your head if you don't give Guru Dakshina. So quickly smash that like button and subscribe. Let's start with the questions coming up on your screen. April attempt, guys. We'll have a separate session for January attempt. Here it comes. The effective resistance between A and B, if the resistance of each resistor is R, will be how much? Okay, now in these kind of questions, what happens is whenever there is a symmetrical diagram, then some of the resistors which are on the line of those symmetry, basically this one as well as this one, gets eliminated because they are on that line of symmetry. This point, and this point, they have the same voltage. So whatever is connected between them gets eliminated. So that's the rule. In fact, if you have watched my lectures also, I have taught this particular trick for finding equivalent capacitance or resistance. Now, once you do that, you can obviously easily see that this branch has a resistance of 2R because both are in series. This branch also has a resistance of 2R, and this branch also has a resistance of 2R. 2R, 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 they three together are in parallel. You can see all these three are in parallel. So when in parallel, what happens? You divide it by the number of resistances. So it will become 2R divided by 3. So that is the resistance of this combination. Plus R is outside in series. So the total equivalent combination between A and B will be R plus 2R by 3 plus R. So R plus R is 2R. So 2R I can take common. 1 plus 2 by 3. This will become basically 3 plus 2, which is 5, right? And yep, correct. 5 2s are 10. So we will have, just check this out. Have we made a mini blunder over here? R, okay, this is fine. 2R divided by 3, perfect, plus R. Oh, I think I just put this 2 extra, my bad. Yeah, so this will be 1 plus 1 by 3, which is 4 by 3. So 2R into 4 by 3, which is basically 8R divided by 3, which is option number A. Perfect. Yes, that's how you do it. Okay, so whenever line of symmetry comes, remove anything and everything which is on that line of symmetry. It converts itself into a simple series and parallel question like you saw over here. These three branches were in series and they themselves with each other were in parallel. Okay, moving on. Next question, guys. A galvanometer has a coil resistance of this much, full scale deflection of this much resistance, so that it will be converted into an ammeter of a higher range. Okay. Hasini, if you are very, very weak, basically, let me tell you, in current electricity and capacitors, watch the ROAR series. I have taken 3 good classes on the entire topic. Please check that out. Lecture 1, lecture 2, and capacitors lecture 1. Okay. Hello, Niku. Good evening, my dear warriors. Yep. All right. So here, what we need to do, just think about the circuit diagram. The galvanometer has this much resistance, full scale deflection of 20 microampere. So what you do is basically think of the galvanometer of 200 ohms. The maximum current which can pass through it is 20 microamperes. So 20 uh, uh, into, I can say, into 10 to the power minus 3 milliamperes. That's the maximum current which can pass through it. But you want to change the range to 20 milliamperes. So imagine 20 milliamperes enters inside, 20 milliamperes enters inside, and you bypass some of it through a shunt resistance like this. So only this much, 20 into 10 to the power minus 3 milliamperes goes through the galvanometer. This is the shunt resistance. Because this is a very small number as compared to this, almost all of 20 milliamperes enters through this particular resistance. Now, shunt means basically two resistors in parallel. So you can see both these resistors are in parallel. That means they will have the same voltage. And voltage means basically current into resistance. So current is basically 20 milliamperes. Resistance is basically Rs is equal to current, which is 20 into 10 to the power minus 3 milliamperes into the resistance, which is basically 200 ohms, right? 20 20 milliampere cancels, so you will have Rs is equal to 10 to the power minus 3 into 200. So shift the two decimals and you will be having zero point 0.2 ohms. So 0.2 ohms is option number C. That is correct. Okay. Yes, Gauri, join in even if you are a little bit late. It's okay. Hi, Siva. Yes. Yes, Hasini, the capacitors lesson, just check this out. Okay, it's there on the channel over here itself. You can go to homepage. You can see my complete playlist, all the sessions which I have done, 11th, 12th. Okay, so check these three sessions: current electricity, capacitors, and equivalent resistance. And if you want, you can watch my very old classes also, Pathfinder, Nurture series. Those lectures also you can watch. Those are very old playlists. Vasu, if I did not enjoy my job, then why would I be here? Okay. I left my corporate job. I was having electronics company, everything I left, and I came to teaching because I enjoy teaching. All right, cool. So let's go ahead to the next question, guys, coming up on your screen. Here it is. The equivalent resistance between A and B. Okay, this is a disguised form, I feel, because I can see some wires getting twisted here and there. Hopefully, I had kept one extra page. Yeah, there is an extra page over here. So we'll try to uncover that disguise and see what exactly this circuit is. First of all, few things very obviously seen. This 10 and 5 technically is basically 15 ohms. This 4 and 11 is also 15 ohms. This 8 and this 7 is also 15 ohms. Yeah, that's about it. So now let's start redrawing this same diagram. It will look a little bit simpler. Observe carefully. So from point A, you have your regular 6 ohms, no doubt about it. This is 15 ohms. So I'll do one thing. I'll just mention that 15 ohms right over here. And that 15 ohms has a point over here, which is this particular point. Then between 6 and this 15, there is a point over here. Let's say I mark it with a cross over here so that you analyze it. So this cross, that cross is directly connected to some other point over here. But before doing that, between this point and even this cross, because these 2 points are connected by a wire, the potentials will be same, right? Wire connects points of same potential. And if this is cross potential, this is also cross potential, some symbol. So maybe I can draw, maybe I can draw one more resistance of 15 ohms over here, and this cross will be directly connected over here. Lastly, lastly, this cross is connected to this dot. You can see this dot is jumping over this, right? Perfect. So I can say that there is one more resistor of 15 ohms, which is directly connected to this particular cross, which is directly connected to this particular cross via this 15 ohm resistance, and this dot is connected to point B. So this particular dot is connected to point B via that resistance of 8 ohms. So this is an equivalent circuit, is what I would say. And what is interesting to note is that this, and this, all these three resistors are connected between the dot and the cross. Dot, cross, dot, cross, dot, and cross. That means these three are actually in parallel. So the actual equivalent circuit for this would be point A, and then you have 6, and then you have basically three resistors. Basically, you have three resistors, and then you have this 8 ohm resistance, and then point B, each one of them being 15, 15, and 15. So 15, 15, 15, basically in parallel, the equivalent will be 15 by 3, which is 5 ohms. 5, 8, and 6. 5, 8, and 6, my dear warriors. What will be the final answer? Quickly think and tell me. Resistance between A and B will be 6 plus 5 plus 8, which is 19 ohms. Is that right, my dear warriors? Yes, 19 ohms is the correct answer. Very good. Awesome. Very nice. Vijay, after this, we'll have Newton's laws, and after that, we'll have, yeah, magnetism. Tanuja, you are a neat aspirant. Looks like you got inspired by some video, and maybe you want to also see some JEE PYQs. Very good. Keep it up. Yep. Yeah. Awesome. Awesome. Uh, Jyoti, don't waste your time here. Yeah. Please don't waste your time. All right. Moving on to the next question coming up on your screen. Here it is. Water boils in an electric kettle 20 minutes after being turned on using the same supply. Okay. The length of the wire should be how many times increased or decreased if the initial length of water, sorry, if the water has to be boiled in 15 minutes. See, very important thing, same supply. You want to use the same supply, means same voltage. So heating the water is given by, the heat supplied to the water is given by V squared by R, and this is actually power. So heat divided by time is V square by R, because V square by R is power. Heat supplied per unit time is this particular thing. Voltage is same, resistance will change, same water but in different time. So time is directly proportional to resistance. But we also know one important thing, that resistance is nothing but directly proportional to the length, rho L by A, right? Resistance is proportional to the length, so therefore time is directly proportional to the length. So hence one can easily say 20 minutes divided by 15 minutes, time 1 by time 2 will be length 1 by length 2. Length, this is old length divided by the new length. So I can say that the new length, if I take it on the top, is the old length. 15 by 20 is nothing but 3 by 4. So it has decreased. It has decreased by how many times? Your 3 by 4 times. That is the correct answer for this question. How many of you got it? All right, no problem, Tanuja. Obviously, JEE Mains questions will serve like a good practice for any examination, not just JEE, but even BITSAT, EMSAT, so many questions. Not 4 by 3, 3 by 4. Be careful, Flambo. Not 4 by 3, 3 by 4. New one will be 15 by 20. 15 by 20 will be 3 by 4. Okay, move on. Move on to the next question. The terminal potential difference of the cell is, okay, I think this was a very straightforward question. Can you see both these resistors are actually in parallel? And in parallel, what happens is the resistances will become divided by the number of resistances. So 4 ohms divided by 2, which is basically 2 ohms. Now this 2 ohm is connected to this 1 ohm. So the equivalent resistance of the circuit will be 1 ohm plus this 2 ohm, which is basically 3 ohm. So hence, if I ask you how much current is passing in the circuit, it will be the voltage divided by the total resistance, which is 3 ohm, which will be then 1 ampere. But the question is not that. The question is terminal voltage. The terminal voltage is always E minus IR, if you remember it correctly. E is 3, current is 1, resistance is 1, so it will be 3 minus 1, which is basically 2 volts. So 2 volts, which is C for captain Shreyas. Very simple, very straightforward. Very good, Siva Kumari. Awesome. Yeah. Can I watch Pathfinder series from 2022 for J25? Yes, Mohammed Ayan. Why not? Those are very good classes. But also stay up to date with the current Roar series because I have kept some new variety, new type of questions also. Pathfinder sessions are excellent. They will definitely build your concepts, and it has been done, over a period of time, and again, small classes. So yes, you can definitely use that, or else you also have the Roar series. Moving on, next question. The number of electrons which are flowing per second in the filament of this bulb at this is how much? Very simple, just calculative questions. So number of electrons flowing per unit time can be calculated by the current. So current is basically charge per unit time. Charge is number of electrons into electronic charge and divided by time. So what I want is N by T, which is basically I by E. But to find out the current, I can do one thing. I know I know that power is nothing but voltage into current. So current will be power divided by voltage. So instead of current, you put power and divide it by voltage. Rest of the terms will remain as it is, which is N by T. Therefore, I will say number of charges per unit time will be all these things over here. Power is nothing but 110, then voltage is nothing but 220, electron charge is 1.6, 10 to the power minus 19, and all of that. Solve this and you shall get the answer as option number B. So logic is a two-step process over here. First logic is over here. What is the definition of current? Second is the formula for power, which is voltage into current. You merge these two formulas together and you will get the answer. Okay, very straightforward. I leave it up to you to calculate. Let's move on to the next conceptual question. The value of the unknown resistance X, which is over here, for the voltage between B and D, B is here, D is here, to be 0. The moment you see this diagram, it should click in your head that this is a question on Wheatstone's bridge. Wheatstone's bridge is an arrangement where you have four capacitors or resistors, and between two the branches you draw anything, there will be no current in it, there will be no deflection in a galvanometer whatsoever, and that only happens if this upon this resistances match. The ratio of the resistances should match for the bridge to be balanced. Is that right, my dear warriors? Okay, so what should the answer be? Let's figure it out. First, what is this resistance technically between points B and C? Okay, so what is this resistance going to be? It is just 1 ohm in parallel. So in parallel, what happens? You divide it. So 1 by 2, which is basically 0.5 ohms. Okay, now this is 12 and 12. 12 and 12 is 24. 12 and 12 is 24. So if one decides to just take all these people together, 24 and 24 will be 24 divided by 2, which is again 12 ohm. So what is the ratio? The ratio is 12 is to 0.5. Okay. So now over here, if this is 0.5, again, check this out. 100%. If this is 0.5, this is just like this. This whole thing must be 12 ohm, undoubtedly. This whole thing must be 12 ohm. Everybody gets this. Now, out of that 12 ohms, you look at only these two resistors. These two resistors are in parallel. 12 and 12 will make it 6 ohms. So if this is 6 ohms, 6 ohms plus what will give you 12 ohms? Obviously 6 ohms. 6 ohms and 6 ohms in series will give you 12 ohms. So the answer is C for Captain Shreyas. So very simply, mentally only you can do it in that diagram. You don't have to sit and calculate or do some complicated maths. Yeah, I hope this is absolutely clear. Everyone? Yeah. What is the weightage of electromagnetic induction, electromagnetic waves, and AC circuit in JEE Mains? How many questions? See, AC circuit has little bit higher weightage, then EMI, and then EM waves depends. Sometimes they might not even ask a question. So totally, if you see these three chapters, expect uh, bare minimum 2 questions, so for sure. In fact, 3 questions I would say. 3 questions and maximum 5 questions. Okay, so that is the approximate weightage of these 3 chapters together. Around very rarely you might get 2 questions only. That is also possible, but on an average 3 questions and maximum 5 questions. Okay, that's what you can approximately expect. All right, moving on. The ratio of heat dissipated per second through the resistance of 5 ohm and 10 ohm in the circuit given below. The ratio is asked. Now, these two resistors are basically in parallel, and in parallel, what happens is the voltage is same. So, because they are in parallel, the voltage is going to be same. So, if I want the ratio of the powers in 5 ohm upon 10 ohm, I can use the formula V square by R. So, V square by R and V square by R. So, V square cancels. I'll just get 10 by 5, which is 2:1. So, 2:1 is option B for IIT Bombay. Very simple. You don't have to sit and calculate current or anything. These data points were useless. Chumma given, no use. Okay, sometimes it happens. You might have seen in many such questions. Right. Moving on to the next question on your screen. A galvanometer of some resistance connected in series with a 400 ohm measures the voltage drop up to 10 volts. The value of the resistance to convert it into an ammeter to read up to 10 amperes is how much? Okay, again, see guys, you are taking galvanometer in series with another resistance. So imagine this 100 ohms with another resistance of 400 ohms. So these two together, maximum voltage that it can measure is how much? 10 volts. So maximum voltage it can measure is 10 volts. So there will be some maximum current which can flow through it. So voltage is equal to current into the resistance, which is 100 plus 400 in series. So 0, 0, 0 cancels. 10 plus 40 is basically 50. So maximum current is 1 by 50 amperes. Now comes the next part where just imagine you still have that galvanometer of 100 ohm resistance. The value of the resistance to convert the galvanometer into an ammeter of 10 amperes. The maximum current which can go through it is 1 by 50 amperes. Is 1 by 50. You pass basically 10 amperes inside it. Most of it should get bypassed via the shunt resistance and again get collected over here. So I want to find the shunt resistance. 1 by 50 is a very small number. So 10 amperes minus 1 by 50 is still approximately 10 amperes only. It's not much different because for 10 amperes, 1 by 50 is negligible, guys. So now we can clearly see these two are in parallel. So voltage is same for resistors in parallel. So current into resistance, which is 10 into RS, will be current into resistance, which is 1 by 50 into resistance. 0, 0, 0, 0. So RS is basically 1 by 5. So RS is basically 1 by 5 ohms, and the answer is expected as something into 10 to the power minus 2. So this is basically 0.2, right? So this will be 20 into 10 to the power minus 2. So this will be 20 into 10 to the power minus 2, which is option B. I hope this is absolutely very clear. Yes, option B, very good, Tanuja Sivakumari. Awesome. Wave optics has got nothing to do with ray optics. Ray optics is a completely independent chapter. Who told you ray optics and wave optics have to be learned together? Yeah, see, mixed questions when it comes, then there is no end. Then any chapter can be related to any chapter. But wave optics, for studying it, you need to know oscillations. 11th standard chapter. And it will be even better if you have some good idea about waves on a string and sound waves. If you have good idea or decent idea, at least the first half of the chapter, wave equation and all of that, interference and all those things, then I feel it will be very, very beneficial for you to understand wave optics, or else you will struggle in interference. Okay, so oscillations is also very important. Ray optics is independent chapter. R1, R2, R3, R4 are given. Battery is ideal. Equivalent resistance of the circuit and the current supplied. Okay, these three resistors are basically in parallel, like you can see. So if they are in parallel, so 1 by Rp will be 1 by R2. R2 is basically 8 plus 1 by R. 3, which is basically 4, plus 1 by R4, which is again 8. 1 by 8 plus 1 by 8 is 1 by 4. So 1 by 4 plus 1 by 4 is 1 by 2. So basically, RP is nothing but 2 ohms. So this is 2 ohms. R1 is how much? 10 ohms. So what will be the equivalent resistance of the circuit? The equivalent resistance of the circuit R1 is 10 plus this whole thing was 2. So that will be 12 ohms. So what is the current in this circuit? Voltage by resistance. So voltage is 12, resistance is also 12. So it will be 1 ampere. So 1 ampere is there in option C and D only. And equivalent resistance is 12 ohms, which is option D for IT Delhi. Yes, perfect. Very simple. I hope this is clear. Spoon and spork, I would suggest on priority basis, just complete mechanics. If you have not done physics of 11th standard, the main part of 11th standard is mechanics. From vectors, kinematics 1D, Newton's law, circular motion, work energy, center of mass collisions, rotation, and SHM. These are the most crucial chapters. Okay, first do that. Once you learn all these things, drawing free body diagram, vector resolutions, how energy works, everything becomes easy. 12th standard portion becomes easier for you. Okay, and oscillations or SHM is important for studying waves, electromagnetic waves, etc. Correct? Awesome. Okay, so do it. I think it will take you good 1.5 months. It will. Mechanics is a big unit. Okay, other units like thermo, fluids are very easy and they are low weightage also. Mechanics is crucial for understanding everything. If a bulb is rated and connected across 100 volts, the power dissipation of the bulb is how much? See, what happens is when you change the voltage, the resistance remains the same, the power will change. Resistance is always a constant. And we know power is nothing but V square by R. So power is directly proportional to V square. So using this analogy, so I can say P2 by P1, P1 is 50, is equal to V2 by V1. V2 is 100, V1 is 200, and it is square proportional, right? So this is half square is 1 by 4. So P2 will be 1 by 4 into 50, which is 12.5. Yes, option C is the correct one. Is that clear? Okay. So whenever the voltage changes, remember it is always the what? It is the resistance which remains the same. The power will change accordingly. All right. So moving on to the next question coming up on your screen. Here it is. To measure the internal resistance of a battery, potentiometer is used. For R is equal to 10 ohms, the balancing point is observed at 500 centimeters, and for resistance equals to 1 ohm, the balancing point is observed at 400 centimeters. The internal resistance of the battery is approximately. Okay, so how to solve these kind of questions? See, what happens is in these kind of circuits where you want to measure the internal resistance, if this is the potentiometer wire, say for example, what happens is you have this particular battery, this internal resistance, okay? One end is connected here, the other end is that balancing point, okay? And then you have this resistance over here. So what happens is this length happens to be, this particular length happens to be proportional to the terminal voltage, to the terminal voltage across the cell, terminal voltage across the cell. And this terminal voltage across the cell is the current in this circuit, current in this circuit multiplied by the resistance, because whatever is the terminal voltage is between these 2 points, which is also between these 2 points. So it is I into R, and current is the total EMF divided by R plus small r. So the length is basically proportional to this number. This is what you should understand first. And this diagram you will know only if you have studied potentiometer. So this is the potentiometer wire. This is the point where the jockey is connected. This is where the null deflection is observed. The terminal voltage across the cell is also the voltage across the resistor, is also the voltage across these 2 points on the wire, which is also proportional to the length of that balancing unit. Okay, so once you get this, you can see there are two lengths, two different resistances. It's just a matter of taking the ratio, nothing more, nothing less. So L2 by L1 will be E2, or I think EMF is the same, right? Uh, just take this out. Yeah, the battery is the same. Yeah. So E into R2 by R2 plus R, whole thing divided by E into R1 upon R1 plus R. EE gets cancelled, and what I'm left with is nothing but R2 by R1, and here R1 plus R, and here R2 plus R. Now you just substitute all the values. L2 is 400, L1 is 500. So 400 by 500, R2 by R1, new by old. So 1 by 10. So this is 1 by 10. R1 is 10, so 10 plus R, and R2 was how much? 1. So 1 plus R. 0, 0, 0, 0 cancels. You just multiply, cross multiply, and solve it for R, and you will get the answer as 0.3 ohms. Okay, so you should get the value of R as 0.3 ohms. Is that understood how to solve this question? Yes. Very good. Very good. Awesomeness. Shall we go ahead? I hope you guys have liked the session. In case you have forgotten to do so, do that right now. Only if you show your support, we will be continuing the classes. And let me tell you, I'm stopping the road series now because I'm not seeing enough attendance. So until I see that seriousness in you, you will not see any roar classes. Okay. So the same thing also works for this PYQ series. PYQ series is continued, but that is provided you show your support. Roar series, it's on a break till you show your seriousness. I want to see your seriousness. Only then you will see classes for road continuing. Right. Okay. Moving on to the next question coming up on your screen. And here it is. To determine the resistance of a wire, a circuit is designed. The voltage current characteristics are plotted. Find the value of the resistance for this particular circuit. Okay. What do we do in this particular scenario? Look at this particular graph. This is total current and this is the voltage as a whole across the whole combination of resistance. So if I divide these two numbers, what I get is the total equivalent resistance. The total equivalent resistance from this particular graph. Take anything like, for example, 4 volts divided by 2 milliamperes. So that will give you 2 divided by milli, which is 10 to the power minus 3, goes on the top, becomes 10 to the power plus 3. So it will become 2 kilo ohms. That is the total equivalent resistance of these two in combination. So I can see these two are in parallel. So I can say 1 by R equivalent is nothing but 1 by R1 plus 1 by R2 because it's in parallel. So 1 by 2 is equal to 1 by 10 plus 1 by R. This is in kilo ohms. Keep that in mind. So 1 by R will be 1 by 10 minus 1 by 2. So LCM is, sorry, 1 by 2 minus 1 by 10, my bad. So LCM is basically 10. So this will become nothing but 5 minus 1. So which is 4 by 10, which is nothing but 2 by 5. So R will become 5 by 2, which is 2.5, but this will be kilo ohms. So answer is yes, 2.5 kilo ohms, which is also 2500 ohms. So this graph, whatever was shown was for the net voltage and the net current. So whatever you got also as the resistance was not R value, it was the equivalent resistance, which was then to be found out using parallel combination. I hope this is clear. Moving on, next question on your screen. A room, okay, at certain temperature, resistance so much, temperature coefficient so much, temperature when the resistance is 62. Guys, coefficient of thermal expansion. Coefficient of thermal expansion, direct formula, nothing more, nothing less. Everybody remembers, apply it, you will get it, nothing more. So resistance at temperature T, R naught 1 plus alpha delta T. RT is basically 62. Okay, R naught is basically 50. 1 plus alpha is 2.4 into 10 to the power minus 4 and into delta T. So 50 goes with 62 over here, 62 by 50, and you can subtract this one, will be 2.4 10 to the power minus 4 into delta T. So this will basically become 12 divided by 50 is equal to, I can write it as 24 into 10 to the power minus 5 delta T. 12 goes with 24 2 times, 2 goes with 50 100 times, 100 goes over here. This will become minus 3. So therefore, delta T will become how much? 10 to the power 3. Okay, degree Celsius. But the question is find the actual temperature. So T final minus original was 27 is 1000. So it will be 1027. So 1027, yes, that is the correct answer. Right? Straightforward. So this was the numerical question which was asked. Simple question but calculative question. That's all. Okay, let's move on to the next question coming up on your screen. Here it is. The current flowing through the 1 ohm resistance is okay, let's see if we can do something about it. None of them are in series or in parallel, nor can I convert it into a single battery, nor do I see it's a Wheatstone's bridge. Okay, so we have no other option. Remember KVL and KCL at play over here. So start assuming some voltages at some random points here. So let's say, maybe this point and this point, the voltage difference is 5 volts. So let's say I take this as 0 volts. So this point's voltage will be 5 volts. Okay, this point and this point won't have the same voltage. Let's say I call this voltage as X. So if this is X, this is 10 volts battery. This is higher, so this will be lower. So this will be 10 minus X volts. This will be something else only. So this will be Y volts. So we'll do it by the method of potentials. Now you can apply Kirchhoff's current law at these two junctions A and C. So let's say at junction A first, if you apply Kirchhoff's current law. Okay, so how will the currents look like? First of all, we have to also assume the direction of the currents. Without that, we will not be able to proceed in this particular problem. Is that okay? So we'll have to also assume the direction of the currents. So let's say, for example, 5 is higher. Example. So let's say the current is coming in here. Let's say the current is going here, and I1 is already shown here. Okay, fair enough. And if I do from here to here, then it will be okay, minus I1, no issues. So if I apply at point, okay, this is one thing. This is at point C. At point A, maybe I can show like this, or maybe I can show like this, and maybe like this. So these are the three currents entering at point A. So current through the 4 ohm, current through the 4 ohm, right? Plus the current through the 1 ohm, plus again the current through the 4 ohm is the total current in, nothing is going out, so it is equal to 0. One of them will be negative, which is okay. No issues, I understand that, but we'll just write it down as this particular equation. Is this fine, my dear warriors? Okay. Now think about it. Okay. Now think about it. How will the equation look like? Current is voltage difference by resistance. What is the voltage difference? Voltage difference is 5 minus x, because I've shown the direction of the current this way. So I'll show 5 minus x voltage divided by the resistance plus I1. The same current will go from here to here. The same current which is going here will also go from here to here. Voltage difference always higher minus lower. So it will be nothing but y minus 10 minus x, whole thing divided by the resistance, which is 1 ohm. Voltage difference high minus low divided by the resistance is the current. And here the current will be again voltage difference, which is high minus low, which is 0 minus x divided by the resistance is equal to 0. So this is equation number 1. This is equation number 1. Similarly, do the same thing, apply Kirchhoff's current law for the junction, let's say C, okay, over here. So what you will notice is the current through the 2 ohm resistance plus the current through the plus the current through the 2 ohm resistance here will be, okay, this is that another resistance 2 ohm, will be equal to the current which is exiting out, which is nothing but the current through the 1 ohm resistance, which will be the current through the 1 ohm resistance. I hope this is absolutely clear, guys. So what is this I2? Voltage difference by resistance. Voltage difference is 5 minus y by resistance is 2. I2 prime is this current, high minus low always. So 0 minus y divided by resistance is equal to I1. I1 is basically high minus low. So it will be y minus 10 minus x whole thing divided by 1. This is equation number 2. Do you see you have two equations, two unknowns? Basically now solve for x and y. Once you solve for x and y, what is the last step of the problem? To find I1, you can find I1 through any of these equations. For example, I1, what will be current I1? I1 will be nothing but voltage difference, which is high voltage minus low voltage, which is 10 minus x, whole thing divided by the resistance. Solving this, you will get the value of I1. Solving this, you will get the value of I1. Yep. Is that clear? So I think the value comes out as 25. So N is 25. That means I1 is coming out as 2.5 ampere. So basically N by 10 is 2.5. So the value of N that you get is 25. That is the answer. Cool. To score more than 85 in JEE Mains APX, you need to solve on a daily basis mains at least 30 to 50 questions, advanced 5 to 10 questions. Okay, that is the uh, run rate required, I would say. But that is provided if you are almost done with the syllabus. But if you're not done with the syllabus, still a lot of portion is pending, then you can lower it down a little bit. You can maybe do 20 to 40 questions of mains level, maybe 4 to 5 questions of advanced level. That's the ratio which you should keep. I'm talking overall subjects together. Okay, that is the run rate which you should at least maintain. Next question. This is a heater, okay, which is actually meant to operate at 1000 watts at 100 volts. But in this particular combination, it ends up operating at a lower wattage because of this series parallel combination. It won't get enough voltage. So the question is, what is the value of this particular resistance? Is that okay? Let's try to solve this question, my dear warriors. Oh my God. Looks like my cough is not trying to leave me, although I want to ditch my cough. Anyways, okay, let's see how do we do this question. First of all, maybe I will need some duplicate slide because I think there is some bit of calculation which might be involved. So for this heater, okay, for this heater, using this particular data, what can I find? Power is equal to V squared by R. So power is 1000, voltage is 100 square divided by R. So R will be 10 raised to 4 by 10 to the power 3, which is basically 10 ohms. So that is the resistance of the heater. So treat these kind of questions like a normal resistor problem. Then it becomes easier to solve. Next important thing, uh, for the heater to operate at 62.5 volts, sorry, watts. So if you use this particular data, one thing is clear, the resistance never changes. So the power has changed because the voltage across it has changed. So again, using P is equal to V square by R, power is 62.5 is equal to V square. V square I do not know, divided by resistance always remains the same. Remember, resistance is still going to be the same. It won't change. So take it over here. V square will be 625. So voltage will be root 625, which is 25 volts. So you know what this means? It just means forget that there is a heater over here. Forget that there is a heater over here. Just think of it as if you have a 10 ohm resistance, and the voltage drop across these 2 points is 25 volts, is basically 25 volts between B and C. But the total voltage given is 100. 25 is dropped across this parallel combination. So the remaining 100 minus 25, which is 75 volts, will be dropped over here. So 75 volts gets dropped over here. Is this logic very, very clear? Out of 100, 25 is dropped across the parallel. So the remaining 75 will be dropped over here. Okay. Now, the next concept will be, because we want to find the resistance, okay, voltage is known. I can only find the current through this part. Oops. Current through this part. How much will this current be? Let's say I call it I10. Current is voltage by resistance. So it is 25 by 10, which is 2.5 amperes. Okay, but I still don't know this current. So I need this current. How much is this current going to be? Current through this particular thing. Let's say I call it I. Voltage, which is 75 divided by resistance, which is 7.5 amperes. Oh, so at this junction, 7.5 is entering and 2.5 is exiting. So one more exit should be basically how much will be this current? It will be 7.5 minus 2.5, which is basically 5 amperes. So this current is 5 amperes. So now we can use that voltage is equal to current into resistance. Voltage is 25, current is 5, resistance I don't know. So resistance will now be 5 ohms. So 5 ohms, yes, that is the correct answer. What a brilliant question. Yes, Harborine, very good. Proud of all of you guys. Proud of all of you. Awesomeness. Awesomeness. Moving on. Next question on your screen. Resistance of a wire at 0, 100 and T is 10.2 and 10.95. Temperature. Looks like a calculative question. That's all. So let's see how do we solve this part. We know that uh, RT is equal to R naught into 1 plus alpha delta T. Alpha delta T. Okay. So how about this? We just take delta R. We just take delta R will be R naught into alpha delta T. This is the formula which I get by shifting R naught on this side, which is the change in the resistance. Now, what I can do for the first part, between 10 and 10.2, the change of the resistance, 10.2 minus 10, original resistance 10, alpha value, I don't know, delta T value, 100 minus 0, 100 minus 0. Similarly, if you consider this with this, then what happens? The change in the resistance will be 10.95 minus 10, original 10, alpha, don't know, change in the temperature, T minus 0. What do you do? Divide both of them. What do you get? 0.2 divided by 0.95. 10, 10, alpha, alpha cancels, 100 divided by T. Perfect. So now you will get the value of T from here. So T will be, take it on the top, take these two people over here, 100 into 0.95 divided by 0.2. Shift the decimal if you want. So it will become 9.5 divided by 2, right? Which is 95 divided by 2, 94, 47.5. So 4.75. 4.75 and this is 100. So this will become 475. But it is in Kelvin. So this is degree Celsius. You add 273 to get the answer in Kelvin. So check it out if it is 748. Yes, 475 plus 273 is nothing but your 748. 748. Is that right? Yes. Everyone with me? uh, Not 750, 2 degrees less than 750. So in numeric type of questions, you need to be little bit careful. You need to give the exact answer. If you don't give the exact answer, then you will get yeah, either negative marks or no marks depending on how the paper pattern is. Yes. Can you watch this lecture for NEET? You can watch this lecture for any exam because concepts are concepts at the end of the day. Okay, moving on to the next question. In the given figure, an ammeter consists of 240 ohms coil, okay, which is this one, in parallel to 10 ohm in shunt. So remember, in an ammeter, there is a coil of some resistance and there is a parallel shunt resistance, which are in parallel. So you will get an equivalent resistance, and then that constitutes as the ammeter. The reading shown is how much? Okay. So first of all, because the coil has this resistance, shunt has this resistance, the equivalent resistance of that ammeter will be 1 by coil resistance plus 1 by the shunt resistance. Coil resistance 240, shunt resistance is 10. So basically RA will be 240 into 10 divided by 240 plus 10, taking LCM and all of that and reciprocals. So this will be 24 into 100 divided by 25 into 10, because this is 250. And just think of it like 250, 0 cancels, right? And this goes by 5 2 times, this goes by 5 times. So this will become 48 divided by 5. So that is basically RA. That is 48 by 5, which I hope this is fine. Yes, yes, yes. Perfect. Okay. Now, once you get this, guys, what is the next point? This resistance is in series with this. So find the equivalent resistance. So the equivalent resistance is 140.4 plus 48 divided by 5. This value is nothing but 9.6 ohms. 9.6 plus 140.4 is 150 ohms. Once I get the equivalent resistance, I can also find the current in the circuit, which is total voltage by the equivalent resistance, which is 24 divided by 150. So current is 24 divided by 150 amperes. If you want to convert it into milliamperes, you do this 24 by 150 into basically 1000. So that will be in milliamperes. This zero will cancel. So do the math and see if you get it as 160. Yes. So you should get it approximately 160 milliamperes. 160 milliamperes. Cool, guys. Shall we go ahead? Thank you, Prasanti. APX, there is a lot of time to go from 60 to 80 plus. 60 means you have average or decent knowledge. There are still some things which you need to study, some things which you are missing, apart from the usual suspects, which is the silly mistake. So don't blame 60 to 80 improvement uh, is not happening because of silly mistakes. No, there is still, because if you are getting 60 marks, there is still some topics which you have to study in depth, or some models of questions which you are not doing or skipping it, either because of lack of time or because of lack of resources or lack of guidance or whatever it is. So please try to solve as many varieties of questions before the exam. Okay. moving on Moving on to the next one coming up on your screen, guys. All right, let's go. Come on. A wire of certain resistance is stretched until the radius becomes r by 2. Stretching until the radius becomes half. The new resistance is x times of r. Guys, in stretching questions, what happens is the volume remains constant. The volume is constant, and volume is basically of a cylinder is pi r square into the height of the cylinder or the length of the cylinder, which is going to be constant. So clearly in this particular question, the radius has become half times. So the square of the radius will basically become how many times? 1 by 4 times. But to keep the product constant, obviously the length has to then increase 4 times. So 4 into 1 by 4 will be 1, which will then be the same thing. So the length becomes 4 times, the radius becomes half times. Now we all know this fact that resistance is rho L divided by A, and area is nothing but pi into radius square. In the top, in the numerator, we just found out that the length has increased 4 times, and in the denominator, the radius has become half times. So square it. Do not forget to square it. So square of half is basically 1 by 4 times in the denominator. If it is 1 by 4 in the denominator, in the numerator it will become 4 times. This 4 is already there. So what will happen to this? That original 4 in the numerator and this 4 in the numerator will make it 16 times the old resistance. So hence the answer should be 16. Yes, it is the correct answer. Everyone? Very good. Awesome. Awesome. Nishant, I've heard you. I'll be making a fresh video for a 5-month strategy with the portion allotment and how you can complete the syllabus and what are the things that you should exactly be doing. I was getting this request and I have already planned this. Just wait for 1 day or maximum 2 days. I'll be making that video. Okay? Cool? Right. Is Tatva material equal to other institution materials? I don't know which institution you are comparing to, so it depends on that also. It's not like that. I won't say that you should say that Tatva is always the best. There are other good institution materials as well, but it again depends on how you are using it and whether all the things are there or not. Sometimes these books keep getting revised. Sometimes they omit certain things, they add certain things. So there are obviously many good coaching modules available in the market. The good point of Tatva is, number one, you have PYQs plus you have different levels of questions, plus you have both mains and advanced content. Third thing is there is no unnecessary theory, to the point theory, which is good for revision. And the last good thing is, like, you can scan the QR code and get concept videos. And what I find good thing about Tatva, and there are few coaching modules maybe who might be doing this, but Tatva, the good thing is they give you solutions, not just answer key. So solutions is very important for every question that is there. So that is there in Tatva module. That's why I say I recommend Tatva. There is some wire and it is divided into 10 equal parts. Resulting pairs, a combination of two parts, are connected in parallel and so on. And now the resulting pairs of parallel combination are connected in series. The equivalent is, oh, interesting question, guys. If you divide 20 ohms into 10 parts, each part will have a resistance of 2 ohm. Now you take such 2 ohm resistances and connect it in parallel. So this 2 ohm and this 2 ohm together will give you how many ohms? This will make it nothing but 1 ohm. This will make it nothing but 1 ohm. Now you take 5 such combinations, because 2 resistors are used here. Totally 10 parts are there. So 10 parts, two resistors at a time. So you will get 5 such things. You will get 5 such things. So you will get basically 5 such things. Each one of them will be 1 ohm, 1 ohm, 1 ohm as such. So you will basically get 1 ohm into 5 basically in series. So it will be having an effective resistance of 5 ohm. That should be the answer. Yes, the answer is 5. The manner in which the question was framed, it feels very difficult, especially because it is in numeric type, no options are there, no diagram is there. But when you actually visualize and draw it and go a step ahead, you will understand it is actually a very straightforward. Will there be gravitation lecture? Yes, Anandu, after quite some time, but we'll definitely have it. Okay, let's move to the next question on your screen. In an experiment, so experimental physics questions have also come, although this is a question on current electricity, but you can also solve it if you have the knowledge of experimental physics. Okay, so what is the question? There is a graph of 1 by theta. Theta is the deflection in the galvanometer versus the resistance. And the graph has some slope, some intercept, everything. The figure of merit, basically the sensitivity, how much current is there per division is how much. Source has an EMF of this much. Okay. Remember, current, remember, current is basically that figure of merit into theta, basically. So current is proportional to theta. Remember, in a galvanometer, more the current, more the deflection. So if you look at the units also, ampere per division, basically ampere per deflection, K will become I by theta. Ampere, theta goes below, basically that deflection which is there. That K is what I want to find. Now current is nothing but voltage divided by the resistance, equivalent resistance. So that is K theta. Okay. Do I know the total resistance? It's a experiment galvanometer. The resistance box is also there. The figure of merit. Oh, so there is a resistance box which is connected to the galvanometer in this half deflection method. So actually speaking, the total resistance will become R plus the galvanometer resistance. This is equal to K theta. Now, since this is a graph of 1 by theta versus R, I will try to frame this equation in that form. So observe what I will do. Bring this theta below, bring these two people over there. Let's see what do I get. So I'll get 1 by theta is equal to K times of R plus G, the whole thing divided by V. Deliberately I did it because I wanted 1 by theta. Now, what do I do? Maybe something got to do with slope and resistance also. So I can just do one more thing. 1 by theta is, uh, okay, K. I can do R and then divided by, okay, perfect. I can do K by V into R plus K into G divided by V. You know why I did this? Compare this equation with, this is your Y, this is your X, this is your M, this is your C. Y is equal to mx plus c, straight line with an intercept. Got it? So now what do you want to find? You want to find k. So look at slope. So our slope is k by v. Therefore, k will be equal to m into v. Therefore, k will be equal to slope. What is the slope, guys? Just check this out. What is the slope? This is 1.5 and 1. So this will be half and this is 2 units. So slope is basically half by 2 into voltage. Voltage is 2. So it is half, which is basically 0.5. So 0.5, which is nothing but 5 into 10 to the power minus 1. This is ampere per division, whatever. So it should be 5. Yes, that is the correct answer. That is the correct answer. Yes, Siva, very good, Herborine. Did you guys love this question? A seemingly a seemingly not so obvious question becomes simple if you understand and apply the concepts. It looks like, oh my God, sir, half deflection method. I don't know. I will just leave the question. No, you have to push yourself, guys, or else you will keep leaving a lot of questions. You will not get 99.99 percentile then. And we have to target 99.99. We are not here for targeting 99 or 98 or 95 percentile. When you study, the mindset should be 99.99 percentile only, no matter what your mock test scores are. Okay, moving on. What do we have? Two wires A and B made of same material, same mass. Wire radius, wire B, another radius. Resistance of wire B is same material, have the same mass. Okay, radius is different. See, if mass is same, material is same, that means density is same. That means volume, therefore, volume is also going to be same. And volume is nothing but area of cross section multiplied by the length. Therefore, area of cross section multiplied by length is going to be the same. Area of cross section is pi into r square. Length is, I don't know, is going to be the same. So 2 millimeters and 4 millimeters. So therefore, think about it. Think about it. If one thing has 2 millimeters, so square it into length 1. Another thing has a radius of 4 millimeters. It will have length number 2. So length number 2 will be 2 by 4 is half. So 2 by 4 is basically half into L1. So it will be L1 divided by 4 because 1 by 2 square is 1 by 4. So the new length is 1/4 of older length. That is the first inference conclusion that we got. But the question is something else. The resistance of that wire is asked. So wire B has some resistance. Okay. So resistance number 2 by resistance number 1, because the resistance is proportional to the length and inversely proportional to the area. So it will be L2 by L1 and it will be A1 by A2. Now L2 by L1, okay, area is pi r square. So I can just say it is R1 by R2 whole square. That is what I can write it down. Length 2 by length 1. Length 2 by length 1 is 1 by 4. Length 2 is 1/4 of length 1. R1 and R2. R1 is 2, R2 is 4. So 2 and 4. Okay, whole square. So 1 by 4. This is half square is again 1 by 4. So this is 1 by 16. So how much was R1? R1, sorry, my bad. The resistance of B, which is 2 ohms. So this is 2 ohms. And you have been asked the resistance of wire 1. All right. So basically R1 will be 32. So 32 should be the correct answer. Perfect. Yes. Hello, Asha. I hope you guys are enjoying this class and I hope you guys are learning a lot from this particular lecture by solving all these PYQs. Okay. Shall we go to the next question, guys? Okay. Wow, we have a cube question. Perfect. And we have 12 wires, each of 2 ohms resistance. To form a cube, the battery of 6-volt EMF is joined across the points A and C. The voltage difference between these 2 points. Okay, let me just create a duplicate. I will need it. With a lot of duplicates. Okay. Now, in these kind of questions, there is always some kind of symmetry. Observe carefully. These are the 2 points across which you want to find the equivalent resistance. If you join this line and draw perpendicular bisector, this will be the perpendicular bisector. But since this is 3D, you consider the whole perpendicular bisector plane, like this, whole perpendicular bisector plane like this. Then you will realize, that actually speaking, all the points on the perpendicular bisector are at the same voltage, Think about it. That means point D and D are equipotential. B is equal to E voltage wise and potential of D is equal to potential of G. That means I can neglect this. I can also neglect this. Did you understand it? I have just drawn the perpendicular bisector of this particular line joining 2 points. That is the trick which I have told you. Whatever 2 points are there, drop a perpendicular bisector. All the points on the perpendicular bisector will have the same voltage, assuming it is a symmetrical diagram. Or else don't do it. Every time you will draw perpendicular bisector then. Only for symmetrical figures. Okay. Then what do we do next? Let's forget. Let's forget those wires which are not needed at all. Let's forget. This is not needed. Yeah, this is not needed. Now, this looks to me like a simple problem because I can see this is one resistance, this is one resistance. So this together, 2 ohms will make it 4 ohms. These two together will also make it 4 ohms. This 2 and this 2 together will make it 4 ohms. This and this together will also make it 4 ohms. These two 4 ohms together, because they are in parallel, right? That will make it 2 ohms. Again, the same thing over here, the same story. This will also make it 2 ohms. Do not forget, there are additional resistances here too. This one is 2 ohms, and so is this one also 2 ohms. So what do we have? 2 ohms, 2 ohms, 2 ohms. And here this is 2 ohms. So this circuit will convert itself into this battery of 6 volts, and you will have this resistance of 2 ohms, this one over here, like this, and 2 and 2 and this 2. Okay, so we'll have this 2, you will have this 2, and you will have this 2 over here, like this, in parallel connected over here. So this is that circuit. This two fours together is this 2 ohm over here. These two fours as 2 ohms is over here. It's in series with this 2 and this 2. So these two twos will effectively then become as how much? 6 ohms. So this is basically 6 ohms. So what is the equivalent? What is the equivalent resistance then? What is the equivalent resistance then? 1 by 6 plus 1 by 2, or you can just do one thing. R equivalent will be R1, R2, which is 6 into 2 by 6 plus 2, which is 12 by 8 divided by 4 is 3, 3 by 2 ohms. Correct? So now we can start figuring out the currents in each branch. The currents in each branch, 3 by 2 ohms. Yeah. So the current in each branch, we can start figuring it out. So the main current will be voltage by resistance. Voltage is 6 volts divided by resistance is 3 by 2 ohms. So 6 by 3 is 2, and that 2 will multiply, and it will basically become 4 amperes. So just check this out. Current will become 4 amperes, my dear warriors. Current will become 4 amperes, my dear warriors. Perfect. So this 4 amperes, which will enter from here, will get divided here as well as here. Will get this 4 amperes, which will come over here, will get divided partially here as well as here. But the ratio will be 1 is to 3, because this is 2 ohms, this is 6 ohms, 1 is to 3. So more current through less resistance, less current through higher resistance. So divide 4 amperes in ratio of 1 is to 3. So this will become basically 3 amperes. This will become 1 ampere. This will become 3 ampere. This will become 1 ampere. So you will see in this part, on that upper part of the circuit, 3 amperes will go, and this part, how much? 1 ampere will go. But the question is between E and F, that is the lower part. So here I just analyze 1 ampere current is going. Now this 1 ampere current will get divided equally here as well as here. So this will be 0.5 and this will be 0.5 amperes. So I think the same current will also go over here. So this will be also 0.5 amperes. So the answer should be 0.5, I believe. Yeah. Oh no, the question is the voltage difference, my bad. Not the current. So once I get the current, we can easily find the voltage difference as well. So the voltage difference is IR. I is basically 0.5. Resistance is 2. So it will be 1 volt. So voltage difference will be 1 volt. So very lengthy question, but solvable. It's not that difficult also, if you are used to cube problems. So whatever cube questions are there, solve it. It's not like cube questions don't come. Okay, perfect. So moving on now to the next question. Yes, we are coming to capacitors. By the way, guys, if you want, I'll make a special video on cube, right, where we solve all the different varieties of cube questions, where once between these two terminals resistance is asked, then once between this and this, and once between this and this. There are three varieties of questions: diagonally opposite, or vertex wise, and then on the same face, and then on the same side. These three questions on the resistors and capacitors, if you solve it now, it is going to be very good. Okay, chalo. Yes, thank you so much, guys. I'll be definitely taking care of my health. I need to do that, or else I think I might not be able to take classes. And that is also one of the reason why I had uh, cancelled or shifted some of my classes in the last 1-2 weeks because of the throat issues. Electric field between two parallel plates are this, drops to 1/3 of its initial value in this many seconds when the plates are connected by a thin wire. The resistance is okay. The question is on electric field. Is electric field related to the time? Not directly, but indirectly. First, I know the charge relationship. Charge is related to the decay or the growth of the current. So I can do one thing. All right. So this is basically discharging of RC circuits where the initial charge is, sorry, and charge at any time is initial charge into e to the power minus t by tau. But we also know electric field is nothing but q by a epsilon naught. Electric field is related to the charge, and charge is related by this function. So I can say E is equal to uh, E is equal to, here I will have here I will have Q divided by A epsilon naught e to the power minus t by tau. This thing is the original electric field. So therefore E is equal to E naught e to the power minus t by tau. Awesome. Now what is the next step? The electric field drops to 1/3 of its original value. So E is basically E naught by 3. E naught is as it is, e to the power minus t by tau. E naught cancels. So 1 by 3 is equal to 1 by e to the power t by tau. So e to the power t by tau is equal to 3. Taking log, so ln 3 is t by tau. Log 3 is 1.1 is what they say. So 1.1 is t by tau. Tau, the time constant, is R into C. So resistance, I think that's what we need to find. Capacitance is 1.5 into 10 to the power minus 6. Okay, so our value will be, take this 1.1 over here into 1.5 into 10 to the power minus 6. This time is given to be 6.6 microseconds. Micro is 10 to the power minus 6. That's it, guys. You will get the answer there. Okay, just check it out. If the answer comes out to be 4. If the answer comes out to be 4, I think you can do it very easily. 11 and 66 goes 6 times. 15 and 6 you have. 6 goes with 3 2 times. 15 goes with 3 5 times. So you'll have 2 by 5 and all of that. And then you can, 2 by 5 is nothing but 0.4, right? And you can write it in the given form. Yes, perfect. See if you guys get the answer as 0.4 over there. For ISER aptitude test, Siva Kumari, that's what you mean? Yes, because you will see that many of the times the questions are very similar level of J. Yep, yep. It will definitely be useful. I mean, J studies never ever go waste. When will you take the lessons? Honestly, Newton's laws is planned. But right now, Roar series, I'm stopping it because of very low attendance. Okay. So until I see that comments, until I see that you are watching the old videos, because we are taking care of so many lectures, we are almost done with so many things. And if we go in full-fledged mode, in the next 2 months, we can complete the entire syllabus on YouTube, guys, as much as possible. At least even 80-90% we can do it. Remaining things, maybe we can do it in some module or some batch or something else. But at least 90%, 80% of the syllabus, we can do it on YouTube in the next 1 to 2 months. So I want your full support. I have been clearly telling you that I want full support. Only then I can conduct the classes. Remember that. Capacitors of capacitance 25, 30, and 45 are connected in parallel to 100 volts. Energy stored in the above combination is E. When these capacitors are connected in series to the same supply, the stored energy is this much. The value of X is how much? Okay, let's see. What do we do? First of all, they are connected in parallel. In parallel, the capacitances will add, and the energy stored in the above combination is E. So E will be equal to half C parallel V square. This is the equivalent capacitance. Cp will be C1 plus C2 plus C3. That's it. So C1 is 25, C2 is 30, C3 is 45. This is all micro. Voltage is 100 square. 25 plus 45 plus 30, that's 100. So by 2 into 10 to the power 4 into micro, which is 10 to the power minus 6. So minus 6 and plus 6 will cancel. It will just become half. So E is becoming half. Till this point, I hope this is clear. E is basically 0.5. Now let's go to series. Now do the same thing, guys. Now just do the same thing. Is connected to the same supply, the stored energy is how much? So basically, that new energy, will be 1 by 2 CS V square. That's all. All right. So yeah. Now what I will do? CS. How much will CS be? CS, I can do it using this formula. 1 by CS is nothing but 1 by C1 plus 1 by C2, that formula. So 1 by 25 plus 1 by 30 plus 1 by 45. So from this you find CS. This CS you put it here, and from this you will get the energy. That energy you will get it as, something 9 by X. This is the X value which you need to give. So it's just calculative, guys. It's just calculative, guys. Yeah, just do it off. Okay. So I think I might have put the calculation part somewhere. Yeah, calculation is over here. The X value comes out as 86. Cool. That part I think you can do. So if you want me to continue, I want everyone to promote, share the classes, get your friends. See, guys, all the students who are learning in English now, there are not many channels. Forget good channels. There are not many channels only. Number two, I want students who want to excel in all these regions, be it Karnataka, Tamil Nadu, Andhra, Kerala, Assam, so many places, guys. Even in West Bengal, so many people watch it. So many people from even Delhi, Mumbai watch our classes. Even people from UAE, even some people from Nepal, Sri Lanka watch our classes. I want all of you to tell about this channel. We are doing this for you. Already so many channels in Hindi are doing good things, and students show that sincerity towards the teachers or the channels. Show that love and that affection. I want the same thing for from you guys. I want you to be very regular. You cannot give excuses, sir, I missed that, or else we will never get ranks, or else we'll never be able to get 99 percentile plus. We have to get seats in NITs, IITs, triple ITs, all these prestigious colleges. You have to push your friends. It's not you alone who will be working. It's not you alone who will be going. You will be taking your entire city. I've been seeing so many students from so many villages, hearing stories like, I was the first doctor, sir. Sir, I was the first computer science engineer in IIT. Because of that particular student, the entire village now wants to go and study in a good college. Because of one particular student, the entire colony gets motivated and starts preparing. So you have to be the torch bearers. You have to be the motivators. You are not the ones who need motivation. You should be the one who will be the motivation for people around you. And you can do that. Trust me. So for that, you need to work hard, be sincere, attend the classes, push everybody else who wants to attend these classes, who wants to get into the top-notch colleges, who still haven't discovered their true potential. Sometimes people don't know what they are capable of, what they are worth of, and you have to show them. Just like I showed you that, listen, you can do this. Okay. Moving on, next question, guys, coming up on your screen. A parallel plate of capacitor is charged by a battery connected between its plates to a potential difference. The battery is now disconnected and a slab is inserted. The change in the potential energy of the slab is asked. Let's have a look. You add a dielectric, battery is disconnected, which means the charge will be conserved because the charge has no place to go. So the formula that I will use will contain charge in the equation, and the best formula to use is Q square half Q square by C, right? Everyone with half Q square by C. Perfect. Okay, so let's think about it. The change in its potential energy, delta U, will be final minus initial. Final will be half Q square by that new capacitance minus half Q square by that old capacitance, initial capacitance. Q is the same. Reason being, battery is disconnected, so Q is going to be the same. Now, I know one more thing, because once you add a dielectric, what happens is, of some dielectric constant, that capacitance becomes K times of the old capacitance. So it will become K times of the initial capacitance. So this is Q square by Ci. Many things are common, like Q square is common, 2 is common, initial capacitance is common. And what I have over here is 1 by K minus 1. Perfect. So what do? Substitute the values. That's all now. Now what is there is just substituting the values. Charge, I do not know. Charge, I can write it as CV. So this will just become capacitance into voltage whole square. So that is what it will be. So if I do that, what will happen? If I do that, this will become CI square VI square divided by 2 times of CI, 1 by K minus 1. CI will cancel. So half CI VI square by 2, 1 by K minus 1. Now I think it's the best time to substitute. Capacitance initially is 12.5 pico. Pico is 10 to the power minus 12. Voltage is 12 square divided by 2, 1 by K. K is basically 6 and this is 1. Even if the answer comes out negative, you just find the modulus of it. Just check it out. If it comes out as 750 picojoules, see if it comes out as 750 into 10 to the power minus 12 joules, which is basically picojoules also. So which is the answer, the filling the blank. Yeah. Close enough to that, Harborine. 748.7 means you will approximate it as 750 approximately if it is not coming out exact. Yeah. And that is what you are going to give the answer as. Okay. So we have come to an end for this particular session. We'll be doing the January attempt problems in the days to come. So stay tuned on the channel. And remember, if you want the 2022 and 2023 questions without missing even one question, just like what we are doing in this series, we're doing all the questions. It's not like you're doing only important or initial questions. No, you're doing all the questions and you want the solutions of it and you want to practice in a hard copy material. That book will be couriered to you at your home address when you buy this particular book and fill the correct details. So that link for buying that book, which is the JEE Mains PYQs of 2022 and 2023, chapter wise, is there in the description box. Okay. And it is available on the Vedantu store at a very affordable price. So you can check out the link. It's probably even pinned in the chat box as we even speak for this particular class. Okay. So do check it out. And I hope that you will be attending all the classes and also telling your friends about this particular channel and about these particular series, which is your PYQ series as well as the road series, so that we can continue. So 899 rupees, you can see all the papers, all the questions are available. Okay, that's the link. Thank you so much. I hope you have loved the session. I hope you are smashing that like button. Let's do, the January attempt in the next class. Okay. Oh, sorry, this is not ray optics. This is supposed to be April attempt. April attempt done. So just leave a comment. April attempt questions are done. Thank you guys. Bye bye. Have a great time. Take care. Hasta la vista. Good night.